One of the most fundamental rules when working with kiln-formed glass is the 6 mm rule. The 6 mm rule refers to the glass's natural physical tendency to assume a thickness of 6 millimeters when heated at or near full fuse temperatures. The full fuse temperature of Wissmach glass is 1460 degrees Fahrenheit. This video will show how Wissmach glass responds to a full fuse firing at 3 millimeters, 6 millimeters, and 9 millimeters. I will also explain how to use dams when working with thicker projects to resist the glass's tendency to flow. The samples on this kiln shelf were fired at 1460 degrees Fahrenheit and held for 10 minutes. The first sample is one layer of glass, or 3 millimeters thick. The deformation you see is referred to as dog boning and will occur every time a single piece of glass is fired to a full fuse temperature. The second sample is a standard 6 millimeter full fuse. It maintains its original shape and has a nice rounded edge. The third sample is 9 millimeters thick. Notice how only one extra layer of glass causes a great deal of flow in the final result. The glass flows out in all directions to assume a 6 millimeter thickness. The final sample is 12 millimeters thick and was fired using vermiculite dams and ceramic fiber paper to prevent the glass from flowing to 6 millimeters. The fired result has a more pronounced square edge that requires some cold working, but maintains its shape profile without experiencing flow. Setting up dams is easy when working on thicker projects. First, let's start by laying the 4 layers of glass, or 12 millimeters, on a primed kiln shelf. I will use 1/8 inch ceramic fiber paper strips to prevent the glass from sticking to the vermiculite dams. Assemble the dams in a pinwheel formation to ensure there are no gaps the glass can flow through. Repeat until all the dams are placed. Once all the dams have been placed, I am ready to fire my glass without risk of the glass flowing. I hope this video clears up any questions about the 6 millimeter rule.